I spent an entire month building 2 performance benchmarking apps using all the primary cross-platform technologies available today: Flutter, ReactNative, Kotlin multi-platform, and of course the vanilla Android. And today we'll be looking at some really interesting performance numbers around scroll performance, memory usage, CPU usage, animation performance, startup times, build times, and a few others. And these numbers are going to blow your mind completely. Software development communities today are filled with fundamental questions pertaining to the cross-platform development. A few examples: Android subreddit is filled with questions like Flutter versus React Native versus Java versus Kotlin. Folks are wondering why hasn't Flutter replaced React Native yet. In the iOS subreddit, folks are confused between web app and mobile, and they're also confused whether to jump to Flutter or stick with native. Similarly, in the React Native subreddit, folks are asking about whether Flutter is dead already, or should Flutter be even considered for hiring. What's even more interesting are the answers, which are mostly based on either past experiences, which is okay, personal biases, which is also okay, or crude understanding of how things are working behind the scenes, which is maybe not okay. So, which brings us to the purpose of this video. This video will provide you an objective view of how things are, at least in terms of app performance, because at the end of the day, it is what matters the most. And for all the subjectivities around the topic, please go and watch my recent videos, starting with Flutter, React Native, Kotlin multi-platform, and then the most recent video, which dives deeper into the technologies behind these three. So my work is based off of 2 existing repositories. The first one is Flutter versus React Native from Naresh Bhatt, and the second one is Flutter versus Native versus KMP by Jacob Ras. So I forked the repository by Naresh Bhatt and fixed a lot of stuff. So first, I ensured that the existing apps are compatible with the latest version of everything, be it Gradle version, React Native, or whatever. I moved the React Native project to the new architecture, and this wasted a lot of my time. I reached out to a few folks in the Discord communities, and they let me know that there is this tool called React Native Upgrade Helper. This tool is interesting. It doesn't provide the diff right away. The diff is there. I had to see what all things I need to change. But anyway.
You suck! You are no talent!
I added the KMP implementation of 2 of the apps. I also added the Android native implementation for 2 of the apps. For all the parameters today, we'll be looking at 2 applications. The first one is a lightweight application, which is written to test the scrolling based performance. And the other one is like a little more involved, which has 200 images in a grid, and all those 200 images are being animated concurrently. Now let's talk about the comparison. Before getting to the comparison, a few notes on how these numbers were measured. So all these comparisons were done on a mobile device, which is Samsung Galaxy A54. The device was plugged in all the time, and I didn't reboot the device. Like all these measurements were done one after the other, because I want to make sure that a reboot doesn't like create new processes or remove the existing processes there, because it could affect the measurements. And also ensuring that all the other app processes are killed every time. Like, well, if I'm doing it one after the other, no other process is starting anyway. But I made sure that the app is killed whenever a new measurement had to be made. All the CPU and the memory usages were captured after letting the app be idle for around 20 to 30 seconds, like to make sure that any initial CPU or memory spike doesn't interfere with the measurements. And all these were captured, like at least the memory and the CPU usages were captured for 30 seconds. And then I took 5 checkpoints and then averaged all those 5 checkpoints. All right, let's talk about, so what we'll do is, like, for every parameter, we will give few points. We'll give 1 point to the winner, and then we'll give 0.5 to the to the runner-up. And we will also give 0.5 in case of a tie only to the winners. All right, let's talk about the list view performance first. The first one is average memory usage. Lower is better. Now, the fun part is that Flutter takes the most graphics memory of all the technologies. I am not 100% sure why, because even Jetpack Compose, I believe it uses a custom renderer. Even that should have used this, like a similar amount of graphics memory. I really don't know. Anyway, so Flutter being the worst at 253 MB, then React Native, which is 130 MB, which is like 35% worse than KMP, which takes 96 MB, which is 12% worse than Android Native. which is the winner, 85 MB. Wow. So 1.2 Android native, 0.52 KMP. Then let's come to list view average memory usage during scroll. Again, the lower is better. Now, a little context here. There are a lot of images on the screen and I wanted to implement auto scroll functionality. Well, the fun part is that on React Native, I actually couldn't implement the smooth scroll. It looks like the API that is there, it doesn't give you a control over the speed. When you are animating from a certain Y to some other Y. So this is how the React Native scrolling looks versus this is how all the other three scrollings look. And also to make sure that I'm capturing the same thing across the technologies, I started the recording the moment I saw the 30th item being visible. So Flutter being the worst, 273 MB. It's worse than React Native by 76%. React Native is at 155 MB, which is worse than KMP by 50%. Then KMP is like 103 MB. Which is again 14% worse than the winner, Android Native, which is at 90 MB. Again, Android Native 1 point, KMP 0.5 points. Now let's talk about list view average CPU usage, as in when the list is static with these animations and no scrolling is there. React Native and the KMP both are around 12%, which is like 9% worse than Flutter, around 11%, which is like 37% worse than the winner, Android Native again. It's around 8%. So winner 1.2 Android Native, 0.5 to Flutter. Maybe I can just remove the Flutter's point because it's very similar to React Native. Okay, just for the sake of it, let's go with 0.5. List view average CPU usage during scroll, and the lower is better again. React Native, which is worse at 16%. Then we have KMP at 14%, Android Native at 12%, then Flutter at 11%. Of course, Flutter being the winner receives 1 point, Android Native receives 0.5 points. Then FPS or frames per second during the scroll. This time higher is better. Now FPS was very tricky. I first tried this very cool tool called flashlight.dev. While this tool looks very fancy and I was really happy that something of this sort exists, but the problem is that it doesn't give the correct FPS for Flutter. Like it was giving 20 FPS and I could tell that it's definitely more than 90 FPS by my naked eyes. And then tried using some libs for React Native and Flutter, which can give the FPS. But then I was like, it's not an apples to apples comparison if I start doing that. Then eventually I stumbled across this GPU profiling option in developer options in the Android phone, which works like a charm. It gives like a proper FPS across all the 4 technologies that we have. And surprisingly, in the case of scrolling, frames per second, it remains almost the same. It's like Flutter, KMP, Android Native, I got the average around 119 FPS. And on React Native, it was 120 FPS. So there is no clear winner. I gave 0.5 to all these 4. Now let's go to the other application, which is the basic single screen image loading, as I call it. 200 images being animated concurrently. And so it's like 3 kinds of animations that are happening. One is rotation, scale, and then alpha. Now, while working on this, I realized that the original benchmarks by Natesh Bhatt had a problem. So in the case of Flutter, it was using 100 by 100 as the cache size for the images in Flutter. Now, the problem is that this the cache size needs to be specified in pixels, and 100 by 100 DPs don't map to 100 by 100 pixels on the Android phones because it depends on the density DPI of the particular device, and hence they needed to be converted. I could tell from my naked eyes that there is a lot of pixelation in case of Flutter, so that's probably the reason why the numbers are better in this Medium article. So I converted these. I also made sure that this is consistent across all the 4 technologies. Okay, let's talk about average FPS. Of course, the higher is better. KMP being the worst. It's like 51 FPS, just 51 FPS, which is very strange. I thought KMP should behave very similar to Android Native. I am not sure what's going on. I tried to take a relook at the code. I made sure that everything is almost same. It is. It's a bit weird. So it was like 46% behind React Native, which is 96 FPS, still better, which is like 19% behind Android Native, which is 119 FPS. Which is in turn like 1.6% behind Flutter, which is 121 FPS, which is the best. And the winner, of course, is Flutter with 1 point. Android Native gets the 0.5 points. Let's talk about average memory usage. The lower is better. KMP is at 170 MB, which is worse, which is like 2.4 4% worse than Flutter, which is 166 MB, which is 25% worse than React Native, which is 132 MB, which is 9% worse than Android Native, 121 MB, the best, of course. Then average CPU usage for React Native and Android Native both, it's like 19%, which is 5% worse than Flutter, and KMP combined 18%, the best. So even in this case, I think there is no clear winner, so I gave 0.5 points to all. Then APK size. So this is also interesting, at least from the numbers point of view. Flutter being the worst at 12 MB because of Flutter engine, 4.3% behind React Native, which is around 11 MB, which is 88% behind KMP at 6 MB. KMP and Android Native, they are like very close. There's just a factor of 0.3%. Android Native, I regard Android Native as the winner, 1 point, and KMP 0.5 points. Now, startup time. Startup time, I think we need to do some kind of knowledge session here, what startup time is. Primarily, it's of 3 types: hot, warm, and cold. So cold means that the app process is not running already. And this is what I'm measuring in this video. On Android, it's further classified as 2 types. One is TDID, or time to initial display. This is time taken for the first frame of the app's UI to be rendered. Now, this is what was measured by the Jacob Rasch repository. Now, the problem is that it doesn't give us any valuable information, because the fact that the first frame is rendered, it doesn't mean that the entire UI has been rendered. It could be a progress bar. You might be loading images from the network or from the disk. So this doesn't give a very nice picture, and I actually didn't want to measure this. Now, the second one is TDFD, or time to full display. Now, this is interesting because this is in the app's control. The apps need to call this method, report fully drawn. And I make sure that I call this after the 200th image is loaded successfully. Now, the fun story with Flutter. So Flutter calls this method internally in the Flutter activity, and I was like, I'm not sure how I can disable that. So I went to the Flutter repository, checked out the code in the Flutter activity, and it looked like it was like a public method which was triggering this report fully drawn. And I basically just overrode that method with an empty implementation, and voila, I just disabled that functionality. And I actually had to write a cross-platform communication channel for all these 3 technologies to report the fully drawn, which was also fun. So React Native at 1.6 seconds worse, which is 11% behind Android Native, which is 1.4 seconds, which is 12% behind KMP, which is at 1.2 seconds. And then we have Flutter at 0.7 seconds, which is the fastest. Now, this, my friends, is just unbelievable. Like, here is this cross-platform technology, which everyone thinks is slower, and it's beating the native Android. And by a factor of what? I don't know if it's like a factor of more than 100%. This is funny. I mean, go check out my my code, try to build it or try to install the APKs, see it for yourself. It is very interesting. Now, the one anecdotal bit around React Native here is that the React Native startup is a bit funny here. For some reason, half of the images appear first and then the other half appears later. Again, not sure what's going on there. All right, we are towards the last, which is the build times. Now, this is very funny. I can let you know the numbers. On Flutter, it was like 1 minute 19 seconds for a clean build. On React Native or KMP, it was 31 seconds for a clean build. Now, this, when I say a clean build, it means is it was built first, and then for the React Native case, I removed the node modules. For the KMP, I did a Gradle W clean. For Flutter, I did Flutter clean. But I don't think this is apples to apples comparison in any way. For example, like in Flutter, if I do Flutter clean, the Gradle caches and the Gradle directory is still there for the Android project, which means that Flutter clean and rebuilding Flutter, it is actually not doing the right thing. So they are kind of inconclusive here, and 0 points to all the 4. Okay, so how's our scoring looking like now? At the bottom, we have React Native with 1.5 points. Then we have KMP with 3 points. We have Flutter with 4.5 points. Then we have Android Native with a whopping 7 points. Woohoo! Yay, Android Native being the winner. I think it's no surprise. See, while it appears that React Native is a bad choice, I would say that these are performance benchmarks which that almost never represent the real world, but they still give you like a worst case to reason about. And again, the choice is never objective, it's always subjective, and which is why you should watch the other videos, like the 4 or 5 videos that I've created. So I plan to write a blog post very soon. I also plan to deliver a talk in some upcoming conference. So if you're an organizer watching this, please feel free to hit me up and I'll be glad to join. And if you're interested in looking at the code, please take a look at this GitHub repository. You'll have a fun time, and let me know if you feel something is weird or why is something written in a particular way. Not sure if you noticed, this spins when I speak. A separate video on what this thing is all about. All right, folks, I guess I will see you in the next one. By the way, please don't forget to hit the like and subscribe button. It really means a lot to me, and it's probably the least that you can do for all the work I've been doing.